Coming to our first work. Okay. Yeah, we're gonna record this and we're gonna post this online. If anyone has a problem, you can direct message me. I'm Almond Robotics. Um, First online was something that we started back in 2020 during the pandemic, and you know, people from 20 states and from across the world came in to learn, and just want to continue that. And today we have Lucas from team 16461 Infinite Turtles to talk about 3D printing. Lucas, would you like to take it away?
Yeah. Thank you for that introduction, Andy. So basically format is just we're gonna run through some slides, and then at the end we will take some questions. Okay, so this is 3D printing for FTC. And just like a quick introduction for me and my team, I'm on team 16461 Infinite Turtles. This will be our 4th year in FTC, and we are from Matthews, North Carolina. And I'm a design lead on Infinite Turtles. Last year I was on 18175, and this will be my 3rd year in FTC. And as far as like accomplishments go, last year we were first Inspire in North Carolina states. We won the World Innovate Award. Oh, whoops. And we had the Software Innovation and Quality Award runner-up at MTI. Okay, so first we're going to talk a little about what 3D printing is. And it's just like a type of way to manufacture things. And it's additive manufacturing, meaning you're putting material down instead of taking it away. And it involves melting material that is usually plastic, different kinds of plastic, to create parts layer by layer, essentially stacking parts layer on top of layer to create a composite 3D part in the end. And so here are a couple of examples of like possible applications for 3D printing. One is like gears you can use to like gear different mechanisms. On the bottom left, there are claws and arms. And that one was an iris capture that we didn't end up using for ultimate goal, but it was a prototype that was made. On the bottom right is pulleys, which are generally used often for power transfer. And that one specifically was used on a drivetrain to power the wheels. And then obviously on the top right, you have aesthetics. You can do some pretty nifty things with multicolor printing. And so like those were sponsor logos that we had on our state spot last year. Okay, so a couple advantages of 3D printing and like why you would want to use this for FTC. First would be rapid prototyping and a quick turnaround time. 3D printing is something, it's honestly the best way to make prototypes whenever you want them. And it's like if you're factoring in things like shipping for like custom or commercial off the shelf parts, it's going to take a lot longer for those to get to you than if you wanted to just print something and test to see if it would work. Next is precision details. Typically with 3D prints, you can model things and they'll be very precise. You can model them down to the millimeter. And so typically you'll have like more mounting options than like commercial parts that you would buy from a vendor like Go Builder or something. Next is that it's like printed parts are obviously going to be lighter than metal, and they're also quite cheap. A roll of filament is around $20, and you're probably not going to use more than like 2 or 3 for your entire robot. And I'm speaking from a team that uses a ton of 3D printed parts on our robot, and so it's a lot cheaper than metal. And lastly, you gain like a lot of design experience and CAD skills from the development process of making 3D printed parts for your robot. But as you can tell, like 3D printing isn't exactly a perfect process, and on the right is like a failed print. And so a couple of disadvantages to this process is that plastics obviously aren't going to be as strong as aluminum or other metals. So it's not always going to be the best choice for high stress situations. You're also restricted by the build volume of your printer, which just talks about how big your bed is. Um, and there are a couple ways to deal with this, obviously, but there are still limitations. Next, it does, like, even though 3D printing is great for rapid prototyping, it does take a while for prints to start and finish because you are making these prints out of very small layer heights. And so while it is great for creating many prototypes, it may take a while for those prints to actually finish, especially if you're on a tight turnaround time. And lastly is that this is like an issue that is slightly getting better, especially on like the like money side of things. But 3D printing still does tend to have heavy upfront costs from actually purchasing your machine. And it also has like costs when you're talking like time wise, because it does take time to learn CAD and tune your printer to print well. So now we're going to talk a little bit about common options used in FTC. And so in the middle is going to be your Ender 3 series. And this is the typical starting budget normal option used for FTC. They vary from around $100 to $250. I believe there is like Micro Center is doing like a promo right now where you can get one for $100. So they are very, very cheap. You can upgrade them with various parts to make it print better. But the reliability and usability of them in general is not the greatest. And so that's where we move into the options on the left and right. So on the left, you have the artillery Sidewinder X2. It's a little bit more pricey than the Ender, but for the extra price, you get a bigger bed. You get direct drive, which is often seen as a better way to move filament, where your extruder gears are mounted on the moving tool head versus somewhere stationary. But a couple drawbacks to that one in particular is stability, because when you are moving a big bed like that around, your printer tends to shake, and the cooling ducts on it aren't the greatest either, but it is still definitely a solid choice. And then on the right is the Prusa Mark. We have the Prusa Mark III or the Prusa Mini Plus. For the Mark III, assembled, it's now $1,099, and for the Mini, it's $459. The bed is comparable to that of an Ender. And like the pros are that this printer is going to be consistent. I've worked with this printer, and it's by far the most easiest printer to get working. It's almost plug and play. And it has like auto bed leveling. It is quite a lot pricier than all the other options, but if you do happen to have the money to spend, I would highly recommend getting a Prusa because of just how easy they are to work with. I've printed on it like many times. I have never had to like tune it. It's maybe failed on me once, but that's not particularly because of the printer. But if you don't have the money to spare, the Ender 3 will do you just fine. You just have to go through some tuning steps, and the artillery Sidewinder is a great option as well. Okay, so now if you've like purchased your printer, you're obviously going to need something to print with, and that's where filament comes in. And so these are the four main-ish types of filament that are going to be used in FTC. The first is PLA. And for the like PLA is typically very cheap and it's very easy to print. It's going to be the easiest filament to print out of all four of these. And I think like in general, it's the easiest type of filament to print, period. And so I would highly suggest starting with PLA, because it's going to make your life so much easier. And then when you start to get more advanced, you can move into some of these other filaments. But PLA does tend to be a little bit less sturdy than something like ABS or PETG, and it also tends to degrade over time, although that's not really a concern when it comes to FTC. Now, I think the second option most teams go with is ABS. In terms of like good qualities about it, it's strong, quite a bit stronger than PLA, but they do tend to like when you print with it, sometimes it can warp off the bed, meaning essentially your print will fail. And then also they produce these like styrene fumes, which do give you headaches. So I would either install a filtration system or keep it in a well-ventilated area to prevent that. Next is PETG. PETG is really durable and it's very highly impact resistant, but it is very tough to print with, and it tends to be hygroscopic, meaning it absorbs moisture over time, which is something you don't want. And then lastly is TPU. TPU is a bit more of a novel filament, I guess you could say. It's a flexible filament, so it's not going to produce like these like super strong parts. It's might be used for something like an intake or like belts or something, but it does tend to be tough to print as well, and it is heavily hygroscopic. Okay, so now we're going to talk a little bit about post-processing, which is essentially something that you would do after you're done printing to give your prints some unique properties. On the left is probably one of the easier ones to do, which is heat set inserts. They're super easy to do, but they can be some of the most beneficial. And essentially what you do is you take these little like inserts and you push them into your print with a soldering iron, and they'll add threads to your 3D printed parts for screws, and it helps better integrate like COTS parts, and it won't round out like your mounting holes compared to like if you printed your mounting holes. Next up is annealing. I'm not like super familiar with this process myself, but the issue with annealing is that while it does increase part strength, it messes with your tolerances quite a bit, because what you're doing is you're essentially heating up the layers to fuse them together, but you won't have the precision of a 3D printer to help you do that, because this is usually done in like an oven or something. Next is vapor smoothing. Vapor smoothing pretty much just uses like chemicals that react with the filament to like fuse the layers together. For ABS, you would use acetone, and then for PLA, you would use THF or ethyl acetate. And then lastly is epoxy coating, where you like use, I'm sure you all know what epoxy is. You can buy it like at a hobby store or something. And it's used for adding strength and smoothness. But one thing to make sure of is to make sure that like epoxy, that like the epoxy you choose doesn't react with the filament you choose, because that can sometimes mess things up. But I will say generally, you won't really need to do a lot of these things aside from maybe heat threaded inserts once in a while, because usually if you're using 3D prints right, you shouldn't need to like anneal them to make them like you shouldn't be using 3D prints in like super high stress situations. Okay, now we're gonna talk a little bit about CADing to integrate or better help your prints succeed. So obviously, in order to print parts, you will first need files of your parts, and these can be made in like any software. Our team uses Onshape. Other people use like Fusion 360, AutoCAD, stuff like that. And there's a couple things to keep in mind when designing parts. The most important is always to use few or no overhangs over 45 degrees. And that's what the diagram in the lower left-hand corner is talking about. So the first two pictures have overhangs less than 45 degrees, but the last one has overhangs that are greater, which means that you will need to print these like vestigial structures to support your prints. It's usually a headache to remove them, so try to avoid them if possible. And then the second thing is tolerances, because while 3D printers are incredible machines, no printer is perfect, and a 4mm hole in CAD can always end up bigger or smaller after your print is finished. So you either need to do print tuning in your slicer, or you need to just like put in the tolerances in CAD. And by tolerances, we mean like maybe offsetting the hole to be like 4.1mm or like 3.9mm. And speaking of slicers, we're now going to go over a couple of slicer settings. And if you don't know what a slicer is essentially you have your CAD file, and then you need to put that CAD file into a slicer. And a slicer does exactly what like the name says. It slices your models into layers, and then it slices your model into layers, and those layers are put into a file called a G-code file, and G-code is the type of code that your 3D printer will read. So as for slicer software, Cura is the most common choice for beginners, and Super Slicer is for more advanced users. I would just suggest starting with Cura. It's honestly great for beginners, and most of the time you won't need to deviate away from it. As far as like slicer settings go, the first one will be wall count. Wall count just talks about how many perimeters you have on your prints as you go up. So you usually want to run with a minimum of 2, and if you want stronger parts, you want to run with 4 or 5. Next is infill, and infill essentially talks about how much of the inside of a part you want to fill. And there's a couple of reasons why we want to use infill. First of all, if every part we made was completely solid, it would be very expensive, it would take very long, and it would be heavy, which are things you usually don't want. And so infill, usually you want to do a cubic or a gyroid infill, because those are going to have the best strength in all 3 axes, because they are a 3D infill pattern, which is usually more preferable as opposed to something like grid infill. Next is speed. Speed does exactly what you would think it would do. It just moves your printer faster. And speed is usually printer dependent. So you wouldn't want to run an ender above 80mm per second. But some printers will be able to go a lot faster. Our team has 2 DIY printers called Vorons, and we tend to run them very, very fast. Next is temperature and cooling. Temperature and cooling, as for temperature, it talks about the temperature on your print bed, and that's a necessary step in order to make sure your prints don't like curl off the bed, and also your hot end temperature, because you do need to melt plastic to put it down. And then cooling, both of these things are really printer dependent, so you will need to research your filament brand and adjust for like whatever filament you're printing. Usually manufacturers of filament are pretty good about including like a little pamphlet in the filament box, so you can just reference that. Yeah, and I covered slicer software. And one more slicer setting, layer height. And layer height, it just talks about, really, it deals with how tall each of your layers are. So if I wanted to do a 1mm print, if I were using 0.1mm layer heights, I would have 10 layers, and if I were using 0.2mm layer heights, I would have 5 layers. And layer height is it tends to have a pretty big influence on on speed, accuracy, and strength. And so if you have lower layer heights, you'll have better accuracy, you'll have more strength, because there are more layers that are fusing together, but it will take a lot longer because you are printing twice the amount of layers. If you have higher layer heights, on the other hand, you tend to sacrifice a little bit of strength and accuracy, but you will print a lot faster. And generally, for most prints, I would recommend doing 0.2 millimeters. That's a really good height to start with. And I almost never change that. And so this is just an example of like composite strength tested at different layer heights. And you can see as you increase layer heights, the strength tends to drop off a lot, and it tends to peak at 0.15. The reason I suggest 0.2 is just because it will tend to be a lot quicker than 0.15, and it'll like factor into like an even millimeter layer height. Okay, now last thing we have to talk about, I think, is print bed adhesion. And this is very, very important because a lot of the times when teams see that their 3D printer is not working, they like go down this rabbit hole of trying to find what's wrong. But most of the time, it's print bed adhesion. It's and most of the time with print bed adhesion, it's that their bed is not level. So actually, I want to talk about leveling your bed really quick. So these diagrams show a bed that is too high, too low, and a bed that is perfect. So when what we mean by bed leveling is that your print bed is not flat, and you might not be able to see it like with your eyes, but those tiny bit of inconsistencies can completely throw off a print. And what I mean by this is if your print bed is just like 0.2 millimeters off, it can completely throw off a print because it's essentially one layer too high, meaning that filament is not going to stick on the bed at all. And a lot of teams have issues with this when they're first starting 3D printing because it's a process that sometimes is just like glossed over. And a lot of people think that 3D printing is something that's like super easy, and like it can be, but you do need to make sure that your bed is level before starting any print. So this diagram does a good job of showing what it will look like if you know your bed is level. If your nozzle is too high, the filament will just droop onto the bed and it will not stick. If it's too low, the nozzle will be digging into the print bed and will be making ridges. But if it is just right, you'll see in the middle of this diagram, it'll look like the layer lines are very close together. And it'll look like a very flat surface and it'll stick very well. Now, if you know that your bed is level and you're still having print bed adhesion issues, there are a couple of things you can do. First, you can just adjust your height down to have that nozzle slightly dig a little bit into the print so that it can just like stick a little bit better. You can wipe down your bed with rubbing alcohol or Windex. Actually, I wouldn't really recommend either of those things because they actually just tend to spread like dirty stuff around. I would just recommend soap and water, wiping that down. Because essentially what it'll do, it'll get rid of any grease that you put on the bed with your fingers that might make the print stick less. And then after you do that, you can either put a light layer of glue stick, some PVA glue and water mix, or hairspray on your bed, and that'll just make your bed like tacky so that prints will stick. Now, if your print happens to be sticking too well, there are also a couple of things you can do. First, you can adjust your height up, or you can do a little spray of water around the edges of your prints to take it off after it's done. And that's because of like the capillary effect. Or one thing I used to do is I used to take one of those like duster bottles, flip it upside down, and then spray it, and that would cool the part pretty rapidly, and it would pop it off. You can use your bed scraper and take like a mallet or a hammer and tap like lightly at the underside, and that usually does the trick. Or sometimes just like wait for the bed to cool after your print, because residual heat is going to keep your print stuck. But if you wait for it to cool to room temperature, you'll usually be fine. You can also just like pop your bed in a fridge or a freezer. Don't do it with metal beds though, because you can warp them, but it is okay with like glass beds. And last thing, another upgrade I would recommend to almost like any printer is just to get a PEI sheet or like a Wham Bam sheet. Basically they're flexible print surfaces that use a magnet to stick down, but when your print is done, you can pop the sheet off and then you can bend it back and forth to get your print off. And okay. Now lastly, we're going to talk a little bit about some like printing resources that you can use to get help. So first is Core FTC. This is a 3D printing guide that was developed by our team 16461. And we are looking into, well, we've already written the guide, but in the next few weeks, we are going to be updating this guide pretty thoroughly. And it'll go over pretty much everything we've covered in this presentation, the same, if not more in depth. And it will also have other stuff for like troubleshooting print failures, as well as like tuning your printers to make them better. Next is All3DP. It's a website and it does a lot of good data tracking for filaments, and it also does printer reviews. Next is CNC Kitchen. He has a website as well as a YouTube channel, and he does a lot of good scientific videos on filaments and print settings. And the strength chart for layer heights I showed you earlier was actually done by him. And lastly, my favorite one, the FTC Discord. This is not just a resource for 3D printing, but if you have any questions regarding FTC, the FTC Discord is the heart of almost like all of FTC. Every day there's going to be like, there are like several thousand people on there that are ready to help you, that are ready to help your team. So if you're not on this FTC Discord already, I would highly, highly, highly recommend joining, and the link is right there. And then for 3D printing specifically, if you want to ask the FTC Discord, I would use the manufacturing channel. And there are a ton of great people there that are ready to help you. Okay. And then now we're going to open up to questions, but really quickly before that, I have my Discord tag up there as well as my email. I would prefer if you reach out to me through Discord if you had any questions. I check my Discord way more than I check my email. And then there's also a presentation link. So if you want to reference anything on this slideshow, I would just recommend like taking a picture of that. And then you can access this whenever. So with that, do you guys have any questions?
Someone in chat asked, can the supports for a 3D print be automatically generated, or does somebody need to add them manually?
Okay, yeah, that is a good question. So typically your slicer will have settings for supports. And so they typically are automatically generated, and you can play with the settings for automatic generation a little. But a feature that some slicers will have is a feature called like paint on supports. So you can like put supports where you want them, essentially. For the most part, supports in the last like few years with slicer updates have gotten good enough to remove, but I would still recommend designing like away from them, if that makes sense. Anything else? Oh,
Someone
okay.
in
Yeah, I saw.
okay.
What is your experience with 3D printed belts, and are they worth it? So what I'll say about 3D printed belts is that they can work and they are good in a pinch if you need them to like prototype something. I personally have not dealt with 3D printed belts, but from the communities that I talk to, they can tend to be finicky. And so I would just recommend buying like a belt from like V Belt Guys or something. Because belts, honestly, they're like really cheap. They're like $1 or $2 a pop. And like rubber belts will do you a lot better than something 3D printed in this instance. And also just like realistically, I think that like TPU is like just tough to print with. Okay, next question. Do you guys have a brand preference for filaments? That's a good question. So typically, most stuff on Amazon, like the top few on Amazon are gonna be okay, like Hatchbox, eSun, Overture. I have used Hatchbox, eSun, and Sunlu, I think. eSun is great. Their PLA Plus is awesome, and I have a roll of ABS Plus that I just ordered. And their filaments are great. Hatchbox is also pretty good. As for Sunlu, I worked with their ABS once, and it was not good. The prints were warping up a lot. That might have just been a batch error for me, but typically I would stick with like Hatchbox or eSun or Overture. Those are good companies. Okay, next question. Has your printer or has your team ever worked with fabricating metal parts via either additive printing, Glowforge, or through milling, CNC, or laser cutting? I know your presentation was just about 3D printing with filament, but I was just curious. Yeah. So we our team does a lot of things with like custom parts. 3D printing is obviously a big part of that. But also we implement metal plates in metal aluminum plates in a lot of our designs, and we get those from a company called Send Cut Send. They are awesome. Essentially you just send them your files, they'll cut it for you, and then they'll send it back, hence the name. But the other good thing about Send Cut Send is they do a lot of sponsorships for FTC teams. And they tend to give honestly a decent discount, and especially for plates that can sometimes get very expensive, that discount is great. You can also honestly like reach out to your local local shops to see if they'd be willing to cut metal for you. And if you can't, because like metal does tend to be expensive, you can also reach out to, or just like reach out to people with like a Glowforge or like another laser cutting, some other laser cutting tool to cut like wood, because those like wood plates tend to also be pretty strong. Okay, next question is, what kind of maintenance are needed after prints? Yeah, so as far as maintenance goes, I'll split this up into like two. First will be the print maintenance, and then also printer maintenance. So as far as printer maintenance goes, first, build your printer right from the beginning, because that will save you a lot of headaches in the future. I would recommend looking up what your manufacturer recommends for keeping your printer maintained. Most of them will just like require like lube or maybe replacing some of the parts every couple months or so. But then as for maintenance after prints, there's obviously the post-processing things we talked about that you can do. But also if you are using supports, you will need to remove those supports. And sometimes if like your tolerances aren't perfect, I would recommend taking like a file or some sandpaper and just sanding it down, because it sometimes it can take a while to reprint. Next question. Okay, yeah, company names. So the company that we use for laser cutting is Send Cut Send. They have a website, and you can reach out to them through email if you are looking for a sponsorship. Okay, next question is, have you ever casted silicone or something else in 3D printed molds? If yes, how did it work out for you? So I myself, and I think our team, has not casted silicone in 3D prints as of yet, but we are planning on casting something in the very, very near future, probably in the next week or weeks or month or so. I would say that casting silicone with 3D printed molds is honestly a great way to utilize 3D prints. It's a lot better to, or I would say it's a lot easier to cast something than to print something like squishy out of TPU. Just because like molds, you can print them out of like harder-ish plastic instead of having to deal with printing like a flexible filament, which can be very finicky at times. Any other questions? Okay, yeah. Thank you, Volk. Thank you, guys. Thank all of you guys.
Thanks for everyone, or to everyone, for coming. I think this will be the end of this workshop. I'll be hosting the recording on YouTube under the First Online YouTube channel. And everyone have a good rest of your day.
Bye.
Bye.